doing some exercises I found online. All right, so let me just share my screen real quick. And then in the second half, Adit will be doing some congruency exercises, I'm pretty sure. So hold on, yeah. All right. So let me see. Wait, you guys can see this so far? All right, yeah, okay, you can. So I've compiled some trick exercises for us to do together tonight. So let's start with question 1. Okay, so these are mostly paper 1 questions because trick questions, like mainly trick questions that come up, never come out for paper 2, like pure trick questions. They'll mainly come out in like different, like they'll ask it differently. It won't be a direct trick question, it'll be more indirect. So today we're just gonna focus on paper 1 trick questions. So let's start off with question 1. Okay, so in the diagram above, find the value of tan theta. So we have theta over here. Oops, okay, wait, let's change color. Okay, so we have theta over here. So as we recall from the previous classes, so ka toa. So since it's tangent, we have to take toa. So tan theta should be equal to the opposite length divided by the adjacent length. So if you look at this, with respect to this angle over here, the opposite will be this one, will be this length here, will be length DC. And the adjacent one, well, it wouldn't be DA, it wouldn't be AD because, you know, this is the hypotenuse as we all know. So the adjacent one would have to be AC. It would have to be this one right here. So right now we know that our opposite is 1 cm, but now what is this? What is this part over here? What is the value of the adjacent? So actually we're gonna have to do a few more steps here. So we see this triangle here. It's a right angled triangle, which means that we can apply the Pythagorean theorem. So you'll get this plus this square plus this square is equal to c squared. A square plus b square is equal to c squared. So just subbing it in, we'll get 1 square plus 1 square is equal to c square. And we will be getting that c square is equal to 2 and c is equal to square root 2. Actually, it's plus or minus, but since the length cannot be minus, we take it as positive. So now we have our AC and our DC. So now we can actually find the value of tan theta. So tan theta will be equal to the opposite, which is 1 cm, and then divided by the adjacent, which is square root of 2. Okay, so now we've actually found the value of tan theta, but I want to go a step further and actually find the value of theta itself. So you can actually just do it by the calculator. Let me just do inverse tan real quick. Yeah, so once you take it and put it in a calculator, you'll be getting something like this. Inverse tangent 1 over square root 2. Another name for inverse tangent is actually arctan. But don't use this in the exam because, like, you know, it's not really in the syllabus. So yes, just use inverse tangent. And then once you put that into a calculator, you'll get 35.26 degrees. So that would be the value of theta. And the value of tan theta is just 1 over square root 2. Okay, now let's move on to question 2. Okay. So let's look at this question. In the diagram above, ABCE is a rectangle and point D lies on the straight line EC. So yeah, point D lies on the straight line EC. Given that DC is equal to, that DC is 5 cm and AE is 4 cm, find the value of cos theta. All right, so as we learned from the previous lessons, this angle, since this is a straight line, this angle should just be 180 minus theta, 180 degrees minus theta. So we have we actually have an isosceles triangle over here. I don't think that's relevant, but yeah, we have an isosceles triangle over here because we have these two little lines here that indicate they're the same length. So we know that this is 5 cm. So now, if we recall from the previous acronym, we can tell that so cos is equal to adjacent over hypotenuse. So we need to identify what is the adjacent here and what is the hypotenuse. So as we can see, the adjacent for here, for this angle right here, for this angle, should be, and this is the right angle. The adjacent for this one should be ED, right? It should be ED. ED should be the ED should be the adjacent, and AE should be the opposite. So now the hypotenuse should be really easy. You should be able to identify the hypotenuse by now, which is the line that is opposite of the right angle symbol over here. So this is the hypotenuse. Now we know what the hypotenuse is, but we don't know what the adjacent is. So there's actually two ways to do this question. So I'll show you guys the first way first. So the first way actually is we can take sine 180 degrees minus theta, and then you just use, since sine is opposite over hypotenuse, right? So we just take the known values already, and we get sine theta is equal to opposite over hypotenuse, 4 over 5. Sorry, it's not sine theta, sorry. It's sine 180 degrees minus theta. All right, and then let's just do the second way first, so that make it easier. So we have a right angle triangle, so that means we can also apply Pythagorean theorem. So you should know by now that if the hypotenuse is 5 and if one of the other sides is 4, then the remaining side should be 3, because 3 square is 9 and 4 square is 16. So you'll be getting 25, and the square root of 25 is 5. So yeah, you should be remembering your, what do you call it? Your right angle triangle like pairs and all that, okay? So actually from this straight away, we can find out what cos is. Cos 180 minus theta is equal to adjacent over adjacent over hypotenuse. You'll get 3 over 5. All right, okay, so we have that one. All right, and now since we have this, we can actually simplify it a bit. We can get cos is equal to, because it's in the second quadrant, right? It's in the second quadrant. So all you have to do is use the quadrant theory thing again. So add sugar to coffee. Sorry. Add sugar to coffee. So in the second quadrant, so this angle right here is in the second quadrant, and the only angles that are positive in the second quadrant are sine. So we can conclude that cos theta is equal to negative 3 over 5. Okay, so the first way is actually, I just realized you'd have to do some additional mathematics in this, but basically what you do is you'd expand the sine 180 minus theta thing, and then you'd have to do it algebraically to find cos theta. So yeah, that's how you do the first one, but let's just forget about the first one because only now am I realizing that it's an add maths formula and not a maths formula. So yeah, let's just forget about that one. So yeah, this is the solution. Cos theta is equal to negative 3 over 5. All right, let's look at question 3 now. A diagram above, PMR is a straight line. M is the midpoint of line PR, so we can straight away mark these two as the same length. Given that QR is equal to 12 cm and sine y degrees is equal to 0.6, find the value of tangent x. All right, so we know that sine y is equal to 0.6. Sine y degrees is equal to 0.6. And we also know that sine y should be equal to the opposite of a hypotenuse, right? So the opposite should be this QR over here. And the hypotenuse should be this QY, sorry, this QM. Let's just draw the rectangle there. So sine Y should be equal to 12 over QM. So now these two are the same, so we can just sub it into each other like a normal simultaneous equation. So we'll get 0.6 is equal to 12 over QM. So we'll get QM is equal to 12 divided by 0.6, and that is equal to 20 cm. So this part here, QM is 20 cm, and we can actually use the Pythagorean theorem again to find MR. So 20 squared minus 12 squared is equal to MR squared. Okay, it's minus because you're minusing the hypotenuse with the other length. So we get 400 minus 144 is equal to MR squared. So we get square root of 256 is equal to MR. And MR is equal to 16. So we can label this as 16 and label this as 16 because they're both the same, because M is the midpoint. So now they want us to find the value of tangent X. So since PQR is another right-angled triangle, we can actually use the same theorem to find the length PQ, because actually, no, we don't even need to find PQ because it's asking for tangent. So tangent should be opposite over adjacent, right? So katawa. And then the opposite of this angle would be 12. And then the adjacent would be 16 plus 16. So that would be equal to 12 divided by 32. You would get 3 over 8. So once again, this is the final answer, but let's go one step further and just find the value of the angle X. So X would be equal to inverse tangent 3 over 8. And if you put that in the calculator, you should get 20.56 degrees. So yeah, that is the value of X. Now let's move ahead with question 4. In the diagram above, WZY is a straight line, and then angle XYZ is equal to 90 degrees. So XYZ, that means the angle here should be 90 degrees. Angle XWZ, XW, so here to here to here, XWZ is equal to 30 degrees, and WZ is equal to XZ, and which is equal to 30 cm. So we can label both of these 30 cm. And now they want us to find the length of XY. Okay, so there are multiple ways in which we can do this. So first and foremost, we can actually find this angle right here. Since we know that this is an isosceles triangle, this angle has to be 30 degrees. And then to get this one is just, to get angle theta is just, theta is equal to 180, which is the what do you call it? The sum of angles in a triangle. And then you minus by 30, and then minus by 30 again. So you'll be getting sine plot. You'll be getting 120 degrees. So theta will be equal to 120 degrees. So now you can actually find this angle, which is just 180 minus 120, which is 60 degrees. And now you can actually, through this, find the length of XY. So this angle here, I would want to find XY, right? So I want to find here, and I know the hypotenuse is 30, so I want something related to hypotenuse. So this angle here will be the opposite. So what trigonometric function can we use to find the opposite and the hypotenuse? Yes, we use sine. So all we have to do is take sine 60 degrees is equal to the opposite, which is XY over 30, because that is the hypotenuse. So we'll be getting 30 sorry, xy is equal to 30 sine 60 degrees. So simplifying that, we'll get sine 60 is equal to, wait, is equal to, I don't want to use the, I want to use the exact formula. So what's it called? Square root 2 over 3? Oh no, sorry, 1 over square root 2. Okay, never mind. We'll just use it as, we'll just do it in the incorrect form because I'm forgetting the basic angles right now. So let's just do 30 sine 60 in the calculator, and then you should be getting 25.9807 cm. Or to shorten it up, we get 25.98 cm. So that is the length of xy. So yeah, that's all you need to do for that question. No further requirements. Now let's move on to question 5. In the diagram above, PQS is a right angle triangle. Yeah, okay, so it's a right angle triangle. We see that here. And then given that SR is 6 cm, let's label that real quick. PQ is equal to 12 cm, label that. And 5SR is equal to 2PS. Find the value of cosine alpha and tangent beta. Okay, so where to start from this? So I would start, first of all, 5SR is equal to 2PS. So the ratio would be 5 to 2, right? Okay, wait, 5 of SR is equal to 2 of PS. So yeah, 5 to 2. And then so basically all you have to do is 5 over 2 times the length of SR, which is 6. So you'll be getting 2.5 times 6 is equal to 15. So we know that this is 15 just based on ratios, you know. So this is 15 cm. And now they want us to find the value of cosine alpha and tangent beta. So cosine alpha should be simple enough because this is we already have the adjacent and the hypotenuse. So cosine alpha should just be 12 over 15 because it's adjacent over hypotenuse. So that is one of the answers. But now we need to get tangent beta. So actually we can just take this one. So 180 minus beta. So you can do it as tangent 180 degrees minus beta is equal to opposite over adjacent. So we don't have that adjacent yet, but since this is a right angle triangle, we can use the Pythagorean theorem as always. So we get 12 square plus 15 square is equal to QS square. So 144 plus 225 is equal to QS square. And then we get 369, square root of 369 is equal to QS. Okay, so, because this isn't a perfect square, you can just leave it in that form. So what you get is opposite over adjacent, right? So opposite over adjacent. So 12 over square root 369. Oh, wait, sorry. Sorry, it should be 15 square minus 12 square. Sorry, my mistake. So you'll actually be getting 225 minus 144. And then you get a square root of 81. And now that is a perfect square. And so QS is actually 9 cm. You can just put 12 over 9 here, opposite over adjacent. And now we just do our quadrant theory again, add sugar to coffee. Since it's in the second quadrant, it should be negative. So tan beta should be equal to negative 12 over 9, but we can simplify that to become negative 4 over 3. All right, looks good. So that's the answer for question 5. Now let's do question 6. In the diagram above, ADC is a straight line. If sine q is equal to 3 over 5 and tangent p is equal to 1 over 2, find the distance of AC. Okay, so sine q, as we know, is opposite over hypotenuse. So the ratio of the opposite to the hypotenuse should be 3 to 5. So if this right here, what do you call it? If sine q is equal to 3 over 5, and sine q is also equal to opposite, which is BD over 30, we can actually sub these two back together to get a simultaneous equation again. So you get 3 over 5 is equal to BD over 30. And just using simultaneous equation, just like timesing 30 on both sides, we can get BD is equal to 18. So let's just label that real quick, 18 cm. And now it wants us to find the distance of AC. So we can actually find the distance of AD first just by using 30 square minus 18 square is equal to AD square. So we'll be getting 30 square minus 18 square. So AD should be equal to square root of 576. And that should be just be 24. All right, so AD is 24. So we know this one, but now we need to find the area, the length of DC. So we know tangent P is equal to 1 over 2. So opposite over adjacent is equal to 1 over 2. Okay, so tangent P is equal to 1 over 2. And we also know that since it's like this, opposite over adjacent, tan P is also equal to 18, the opposite, and then adjacent, which is DC. So now, as always, we can sub both of these into each other. 1 over 2 is equal to 18 over DC. And just from that, we can see that DC is equal to 36. Okay, just cross multiply right over there. So we know that this is 36 cm and this is 24 cm. So now all we have to do is simple addition, 36 cm plus 24 cm, and you get 60 cm. Oh wait, no, 70 cm. Oh wait, no, sorry, 60 cm. So yeah, AC is, the length of AC is 60 cm. Okay, let's do the next question. Okay, so we have some objective questions over here. Yeah, seems like the rest of these are objective. Okay, let's just do these real quick. So, question 7. Which graph represents y equals sine x for 0 to 270 degrees? Okay, so for y is equal to sine x, we know that, let's have a quick recap. So y is equal to sine x. Should be like this, right? It always starts from 0 and it looks like a wave. Okay, and then this should be 90, 180, 270, and 360. Now now a cosine graph, on the other hand, will look like this. So it actually starts from 1. Sorry, the maximum is 1 for the sine, and the minimum is actually also -1. So it'll actually look like this for the cosine graph. Kind of looks like an upside down bell. I can draw this correctly. Hold on. All right, so the minimum is -1 and the maximum is also 1. So the 0 would be 90, and then this part will be 180, and then this part will be 270, and the final part here will be 360. So as we can see, the cosine graph is actually just the sine graph, but starting from here. Okay. Like if you extend the sine graph a bit over there, it's actually just the cosine graph again, but just extended. So yeah, that's something cool in relation to sine graphs and cosine graphs. And as we know, the tangent graph is completely different from both of these graphs. Let's just sketch it out. So as the same as sine, it starts from 0, but then it actually goes up infinitely, and then you get these asymptote lines. Okay, and then this asymptote line is actually 90 degrees, and then you get something from below here, and then you get all the way up there, and then you have another asymptote line here, which is equal to 270 degrees. Okay, and then this is actually equal to 180. And then you'll get another thing all the way from the bottom up here until here, which is 360 degrees. So you might be wondering, why are there asymptote lines at 90 degrees and 270 degrees? So as we know, tangent x is actually equal to sine x over cosine x. So say, for example, tangent is equal to 90 degrees. So we get a sine 90, which is 1, and cosine 90, which is actually 0. Okay, so we'll be getting tangent 90 is equal to 1 divided by 0, which can't happen because if you divide by 0.001, if you divide by 0.001, you get 1,000, right? If you divide by 0.000001, you get an even bigger number. So if you divide by 0, the option will just tend towards infinity. So that's why you have the asymptote lines. It never actually touches the asymptote lines, but it goes higher and higher and higher. All right, so that's the reason why we have those asymptote lines. Now let's go back to the question after we've done all those recaps. So which graph represents y is equal to sine x for 0 degrees? So we know that for 0 degrees, a sine graph always has to start at 0. So from process of elimination, we can already eliminate A and D. So now it's either B or C. So this is just a simple y is equal to sine x graph. So it should start ascending. It should start by ascending, because even if you put in your calculator, like for example, sine is equal to 70, okay, like 70 here. If you put into your calculator real quick, sine is equal to 70, you get a positive constant. Okay, so this would be equal to 940. Okay, and for example, it wouldn't be equal to negative because that just wouldn't make sense, wouldn't it? So yeah, it's a positive number. It's a positive coefficient in the 70 degree plane. So we know that our answer cannot be C, it has to be A. You can actually do this without doing any calculation at all. Just remember the shapes of the sine x, the cosine x, and the tangent x. But yeah, we like to do calculations because it helps us understand a bit more and find out a bit more intuitively why things are the way they are. Okay, so let's look at question 8 now. Which graph represents y equals sine x for 0 degrees? For y equals sine x for x is in between 0 degrees and 180 degrees. So we know that sine x, it has to start from 0. So yeah, all of these pass the test. So now this starts ascending downwards. So we know this can't be correct because it's just a y equals sine x graph. So this also starts ascending from downwards, so that can't be the answer. Okay, but now it's asking for between 0 degrees and 180 degrees. So which one will you choose? A lot of students will actually choose C, but that's the incorrect one. Why? Because if you put it into, because they're asking from a range of 0 degrees to 180 degrees. Sorry, for a domain from 0 degrees to 180 degrees. So if we recall from the graph just now, let's just scroll it back. From 0 degrees to 180 degrees, it's only from here to here. It's only from here to here. Oops, sorry, let me get rid of that real quick. Okay. Yeah, it's only from 0 to 180. And as you can see, it's just a simple bell. If they're asking for a range from 0 to 360, then that answer will be correct. So the answer for question 8 cannot be C, because one thing, it's not asking for the full domain. And another thing is just not correct. So it should be D. So next question. Which graph represents part of sine y is equal to sine x? Okay, so all these graphs look the same, but the only thing that differs is the values. So this one, I'm sorry, but you just have to rely on rote memorization. So we just know that 45 cannot be correct, because if you put sine is equal to 45, you actually get 0.7. Should be 0.7 and not 1. And then sine 30 is the same thing. So the only value that gives 1 is 90 in these options. So we can cross off all of these and then just put A. All right, now we have a question, a more interesting question, which asks, which of the following graphs represents cosine 2x? So as we know from most graphs, 2x actually means that the cycle repeats twice. So instead of just one cycle over here, you actually have 2 cycles in one like 360-degree domain. So as we know, cosine 2x has to start from 1 and not 0 or -1. Like y is equal to negative cosine 2x. That would mean that the graph starts from -1. But since it's just a plain old cosine 2x graph, we know it has to start from 1, so we can straight away eliminate A and B. Now, D would be a normal cosine graph. So this would be y is equal to cosine x, because it goes all from it shows one cycle in the from 0 degrees to 360 degrees. But in the question, it asks for cosine 2x, which means that, just remember the coefficient inside here means 2 cycles in 360 degrees. Or like, for example, cosine kx, that's the general formula, k cycles in 360 degrees. So that means in 360 degrees, the pattern repeats twice. So we can see here, there's one pattern there, and then here, another one, another pattern. So there's 2 patterns, 1, 1, and then you get 2. So we can eliminate D, and we can conclude that our answer is C, because there's 2 cycles in a 360-degree. Now let's look at question 11. Which of the following graph represents y is equal to cosine x for 0 degrees to 180 degrees? So as we know, cosine has to start from 1. So we can eliminate A, we can eliminate B, we can eliminate C, and we can actually just go ahead and pick D, because that's the only answer that starts from 1. So as you can see, it's a very powerful tool, knowing where the graph starts, because you can just eliminate all the answers that aren't relevant, and then just pick the answer that you know is true. So yeah, D is the answer for 11. Now let's look at 12. So we have 3 more questions here. Okay. So which graph represents part of y is y equal to cosine x? So it's a part of y equals to cosine x. If you remember from the thing, it starts at 1, and then it goes to 0 at 90, and it goes to -1 at 180, then 270, it goes to 270, and then it goes back to 1 at 360 degrees. So which option gives us the same visualization as this one? Can't be A, because it's 60 and 180, and that's not 90 and 270. Can't be C, can't be D. So the only option is A. The only option is B, because that's the only one that gives us the thing. Actually, if you put into your calculator cos 90 degrees and cosine 270 degrees, both of these you get 0. And it matches up with the graph, okay? Because it's on the x-axis is 0, right? So yeah, if you cosine 60, cosine 180, they're all like either positive or negative real numbers. They're not 0, unlike 90 and 270. So that's one way you can trial and error your objective questions. But best way is to remember the shape of the graph and all the properties. Okay, on to the second last question. Which of the following graphs represent y is equal to tangent x for 0 degrees to from 0 degrees to 360 degrees? So as we looked at just now, so there's only one, so it's only one cycle between 0 to 360 degrees. So this one counts as one cycle. This one counts as actually 1, 2, and then it cuts from here to here. So it actually counts as 1.5 cycles. And this one just doesn't start from 0 at all. So we can say that's wrong. Doesn't start from 0 as well for D. So that one is wrong. So we actually know that there's only one cycle. So the answer should be A. Okay. If this graph would actually be y is equal to 1.5 tan 1.5x, or y is equal to tangent 3x over 2. Okay, so that would be that graph. But the simple y is equal to tangent x is just this graph right here. All right, so now let's move on to the final question, question 14. Which graph represents part of y equal to tangent x? Okay, so we know that this is just a simple tan graph. So let's just rewrite the tangent graph right here. Y is equal to tangent x. We have our asymptote lines at 90 degrees and 270 degrees. Now let's just extend that line a bit. So we know that it has to start up, and it has to start from all the way down, up again, and then it has to start from the bottom to this part again, which is 360. So we can straight away eliminate A and B because we know that a tangent graph has to go upwards when it starts out from 0. So A and B is straight away out. So now it's either C and D. So let's look at C. Okay, this matches up with our visualization over here on the graph. Now D. So as we can see, this would actually be the asymptote line. Okay, the asymptote line would be at 90. Because actually, if you put tangent 90 into your calculator, you'll get a math error. That's because you're dividing by 0, as I stated just now. So yes, we definitely cannot consider D because it goes past the original asymptote line. So the only answer can be C lah. So that is our answer for question 14. So yeah, these are basically all the past year questions based on trig that they have asked so far. I hope you've learned something, and I'd like to pass it on to the next tutor, Adit.
Okay. Okay. Thank you, Idris, for your lesson just now, and I shall proceed with recapping congruency and transformations. Okay, so I should start sharing. I'll start sharing when Idris stops sharing his. Okay, so we'll begin with some math questions. Okay, so of course I'm not going to go through there because those are difficult. Okay, so we're gonna begin with some basic ones first. And I may or may not call out some people to help answer these. Okay, so diagram on the right shows two similar geometric objects. Calculate the value of y. Okay, so you may you may choose not to answer if you're too shy or like afraid to, but it would be a great honor if you would answer as well. So okay, so first thing we want to do is we have to find out what side y is congruent to. So why is it not working? Okay, give me a second. I'm in pain. Okay, so okay, hold on a bit. There's some technical issues in my Jamboard, which I cannot seem to resolve. Give me a second. Okay, there we go. Okay, so the diagram on the right shows two similar geometric objects. Calculate the value of one. So as we know, these two are congruent based on the question itself. They're similar. Essentially, this means that their shape is the same. It's just that their dimensions and their rotation might be different. So now we want to find which side y is congruent to. So, okay, if I were to ask this right now, okay, let's take y for example, and we're gonna compare it to three different sides. One, okay, let's take this as A, B, or C. Which one is y congruent to? Does anyone know the answer? If no one knows the answer, then I can explain. Okay, so let me explain the question itself. So essentially, this y, as you can see here, is the shortest edge to this whole thing. Is the shortest edge to this shape. And if you look at it closely, you can see that this and this edge is similar to this and this. So therefore, we can say that y is over to 6. So when it comes to congruent, you can put it in a ratio form like this. When for this shape, it's 6 cm, and for this shape it's y cm. We still don't know what y is. Whereas so now we want to find what the ratio of this to this is. So we have to find another edge that is congruent. If we look at this here, 8 cm is congruent to 4. If we look at this here, we can see that over here, these edges are similar to these edges. And it's also like this. And this is also the longest edge of the original shape. So if you're looking at the congruency, 8 cm would be comparable to that of 14. So now that we know that 8 on this side is similar to 14 on the 14 cm side over here on this shape, then all we need to do is find what's the multiplier that brings 8 to 14 and 6 to y, because these two multipliers will be the same, since all we're doing is just enlarging both of them. So to begin, we shall look into it as follows. So this means that 8 times x, for example. Let's take the multiplier as x for now. 8x is equal to 14. So to find x, we just need to move 8 to the right side, and we get 14 divided by 8. So now we know that the multiplier is equal to 14 divided by 8, as like so. 14 divided by 8. Or 14 over 8, basically. And over here, it would be the same thing. 14 divided by 8 as well. So all we need to do to find y is we just multiply the 6 by the multiplier. So it'll be 6 multiplied by 14 over 8. You'd get, and you can put this into a calculator because all your exams will be done on calculators. You'll get 21 over 2, and this will be your final answer, basically. So this is how you get y, So this is how you get y. So when it comes to congruency, you just need to find which sides are similar to each other and then compare them from there. Because as you can see, this was enlarged to become this in a way. And we want to find how big the enlargement is. So if 8 was enlarged to 14, then we want to see then the multiplier will be 14 over 8. So therefore, 6 will be multiplied by the same enlarger to become y, in a sense. And this y would become 21 over 2. Okay, does anyone have any questions? I'll give 30 seconds if you guys have any questions. If no questions, then I shall proceed. Okay, the diagram below shows that Q is the image of P under enlargement. Describe the enlargement. So, for enlargement, you have to look at two aspects. These two aspects being, 1, the scale factor, and 2, the center of enlargement. Okay, so first let's look at the center of enlargement first. In order to find the center of enlargement, you must draw a straight line from the points that are congruent. For example, if you look closely, you can see that these 2 points are similar. And then therefore you can connect them like this. And once you connect them, you have to extend them for as long as you can. Or within reason, obviously. And from there, you can just connect every other point that's similar. For example, we take this one and this one. Well, not every, just connect 3 to be safe. And this one and this one. And then you can see that all of them will go from a certain point. They all intersect at this point over here. Now then, over here, at this point, you can see that this is known as what's called the center of enlargement, where these lines connecting the points of the congruent shapes will intersect. And this center of enlargement is known as you can see, is coordinates 3, 3. So that's the first part. The second part we need to find out is the scale factor. So I'll just erase all of these. And I'll leave the center enlargement there for future reference. Okay, so to proceed, if you look at for scale factor, you must understand that the formula for scale factor is equivalent to opposite image side divided by object side. So if you're looking at it like this, okay, let's take the shape for example. And then we can take like any side on the shape. So we take the image that is Q. So from the statement we know that Q is the image of P. So Q is the image, P is the object. So let's take any side. Let's say that we take this side, for example. This side over here is 3 units. And this side is congruent to this side, because you can see that they're the same thing, basically. So this side is 1 unit. So scale factor. So the scale factor would be image side 3 divided by object side, which is 1. And this will equal to 3 divided by 1, which is in the end equivalent to 3. So therefore your scale factor shall be 3. Simple as that. So now we know that both the two important aspects, that is scale factor and center of enlargement, we can finally put the how to describe the enlargement, which would be the statement would be something like this: enlargement of scale factor 3 from the center of enlargement enlargement 3, 3. This is how it will work. So yes, this is the first part of the whole thing. The next part is okay, so any questions so far? I'll give 20 seconds for any questions. If you're clear, then you can just type clear. All right. Thank you, Harin. Do you want me to call you Harin or Morgan? Sorry.
Anything.
All right. Then I'll call you Harin. Okay, so the next one. We shall proceed to the question 4, which is, it is given that the areas of shape A and shape B are 18 centimeter square and 32 centimeter square respectively. If shape B is the image of shape A under enlargement, determine the scale factor of enlargement. Okay. So, okay, if we're looking at this, oh crap, wait. The scale factor enlargement, this will be difficult if you don't know the formula. So you make sure that you remember the formula. Actually, they'll give you an exam, so you don't need to memorize it. Your formula will be image size, area of image is equal to scale factor squared. Remember, scale factor is called K. They usually refer to it as K. Scale factor squared multiplied by area of object. Now, let me just check if this is correct. Don't worry, I have the utmost confidence that it's correct. So give me a second. But you can never be sure. When it comes to studying, you have to always put the mindset that everything you know might be wrong. And you have to make sure that you can find ways to prove that it's correct. So you have to just make sure every single time. So when it comes to enlargement, their formula will be, yes, area of the image is equal to K squared times area of the object. So, okay, Harin, which one is the image? Shape B or shape A, based on the question?
Is it A?
Good try, good try. But the image is shape B because, as you can see, it says that shape B is the image. But that's a very good attempt. Shape B is the image of shape A. So therefore, if it says image of shape A, it means that shape A is the object. Does that make sense?
Yeah, sorry, I didn't read the question just now.
It's okay, it's okay, it's okay. So yeah, shape B is the image, shape A is the object. But good try. So yes, shape B is the image, and shape A is the object. So from here, we can type that shape A, area of image, which is shape B, is 32 cm. And the scale factor is K. Is K. Well, scale factor we don't know. It's just K. I put K squared because I still don't know yet. And then we multiply that by the area of object. Okay, so Harin, can you tell me the area of the object, if you don't mind? You can take your time, don't worry. Don't need to rush.
Is it the 18?
Yes, that's correct. That it's 18. 18 is the area of the object. All right. Okay, good one. So now we know that 32 equals to K squared times 18. So how do we find K squared, Harry?
I move the K square in front. Then you have to take 32 and 18. And then you have square root.
Yeah, that's correct. Okay, good. You're still it's good to know that you know the syllabus quite well. So the 32, so K squared is equal to 32 over 18. And from here, you can just square root when you get K to get K, which is equal to, okay, wait, let me check if I have my calculator on. And 32 over 18, and you'll get 32 over 18 is equal to 4 over 3. And that's your answer. Okay, any questions? Yeah, that's basically the final answer. Oh, wait. Yeah, actually, yeah, that's fine answer. So now that we put k is equal to 4/3, k, as we know, is scale factor, so scale factor is equal to 4/3. Okay, understand? Okay, if there's no question, then I shall move on to the next question. So the diagram on the right shows that point A lies on the Cartesian plane. It is given that transformation R is translation R 5, -2, and transformation S is a reflection on line y equals 7. State the coordinates of the image of point A under combined transformation RS. So we have combined transformation RS. So the first thing you need to do is, which one should go first, R or S?
S.
Yes, that's correct. Thank you, Hari. So S will go first, which means that we have to do a reflection of y equals 7. So, okay, tell me, is y equals 7 the red line? Oh crap, wait, it's still not straight, no? Okay, give me a second, This is pain. Okay, give me a quick moment. Okay, so we have this red line. It's not really red, but you get the idea. And we have a green line. So is y equals 7 the green line or the red line?
The red.
Yes, that's correct. Thank you, Hari. So we shall go on to, we can see that the red line is the line of reflection. So line of reflection means that this dot will be reflected on the other side, like so. So since this is three units away from the mirror, the image will also be away from the reflection. Actually, no. Yeah, the image will be three away from the line of reflection, and you'll be landing over here. So now, okay, now we can try write. If you're writing an answer, you have to write it like this: A 3 4 under transformation S like this, and then you write the next coordinate. So what's the coordinates after S? The origin is 3 4. So what's the coordinates up here? If you're not sure, then I can explain. But yeah, basically reflection works like that. Reflection is like
So can
3.
you repeat your question?
Oh yeah. After the A goes under transformation transformation S, what's the coordinate of the dot after it transformed S? So like, what's the coordinates over here?
Is it 310?
Yes, that's correct. Thank you, Hari. So yes, the answer is, the first answer is 310. This they will award you 1 mark already because you showed that you put the first transformation S. But is that the final answer? These are usually a 2 mark question. But yeah, this is usually not the final answer. Actually, no, it's not. It's definitely not the final answer because we still have 1 more transformation left to go, which is R. So, give me a second. So now we have transformation R. I mean transformation R. Transformation R is the basic translation, which is translation 5 -12. So 5 -12 means that it will go. Okay. Okay, this 5 -12. So I like to ask, the 5 over here, is this the movement on the x-axis or the y-axis?
The X.
Yes, that's correct. Okay. So we'll move on with this. It'll move 5 units to the right. because this one is positive. So wait, I'll zoom in. Oh no, wait, that's not good. Give me a second. Let me just clear all drawings. Okay, so once we're here, we already reflected the A to up there, which is 310. So now we remove transformation R, which is the units, it goes 5 units to the right. 1, 2, 1, 2, 3, 4, 5. It goes here. And then -2. 1, 2. It goes down 2 because negative. So now we go over here. So what's the final coordinates, Harry?
8, 8.
Yes, that's correct. Thank you, Harry. So we have the final one is 8, 8. All right. So this one is going quite smoothly. So, okay, these are the most commonly asked questions in exam. So if you're able to do this, then you should be able to get, if you're able to do all of these, then you should be able to get 2 marks each, basically. But sometimes they ask you like harder questions, which I'll go on, which I'll describe later on. So the diagram on the right shows that F is the image of D under a combined transformation GH. It is given that transformation H is a reflection on line x equals 6. Describe transformation D. So we first start, okay, so which one goes first, G or H?
H.
Yes, that's correct. Thank you, Harry. So yes, we start with the one on the right side first, which is H. So we do a reflection on the line x equals to 6, which is over here. Actually, wait. Harry, do you know how to use the annotate the drawing on Zoom?
I'm not quite sure about it.
Oh, okay. So, wait, are you on laptop or are you on your phone?
Phone.
Ah, okay. Then, Then okay, I'll continue. But on PC, there's a way you can draw on like the other people's streams. So that is something that can be done. So, okay, with that in mind, okay, jap Give me a quick second. So now we have line x equals 6, which is over here. So line x equals 6, we'll have a reflection on line x equal to 6, which means that from D, remember D is the object, the initial object, and it reflects to here. So this something, you'll get something like this because it's reflected to the other side. Okay, so from here we have the first reflection. So from D, we go here. And then after that, we need to find out how do we get this green arrow to F? How do we get green to become F? So, Harry, do you have any idea which of the 4 transformation it is? Like, okay, wait. Before you answer that question, don't forget the 4 transformation, which are translation, reflection, enlargement. Actually, it's not 4. Is it 4? Yeah, it's 4 now. Enlargement and rotation. So which of these 4 can bring the green arrow to F?
Is it the rotation?
Yes, rotation, that's correct. Okay, very good. So now we know that it's rotated. Is it rotated 90 degrees clockwise or anti-clockwise?
I think it's anti-clockwise.
Yeah, anti-clockwise. Very good. Yeah, clockwise is sometimes when you first learn this topic, it's very difficult to tell between clockwise and anti-clockwise. But if you're struggling with that, okay, but you might not be struggling with that lot, but as a tip for anyone that might need it, clockwise is basically like a clock, basically, because the minute the hands go from left to right like this. So as time passes, it'll go clockwise. Anti-clockwise is the opposite. So like just think of like time going backwards. That'll be anti-clockwise. So clockwise is moving with the clock, and anti-clockwise moving against the clock, basically. Okay, so yeah, this is a rotation of 90 degrees anti-clockwise. Rotation 90 degrees. 90 degrees. Okay, I'll just type degrees for now. But don't forget you can use the symbol as well. Anti-clockwise from the center of rotation. Okay, so this one is something that I used to struggle with a lot, which is the center rotation part. So center rotation, this one you have to try to like look at the shapes and see where they meet. So for this case, you know there's a 90-degree anti-clockwise. So we can try doing something like this. Like try making an L shape. Okay, wait, no, that's the wrong L shape. Give me a second. So we take this point over here at the tip of the arrow, and we try finding a way to connect it with the other tip of the arrow, which is up here. So we have two tips of the arrow, 1 and 2. So from here, we can try doing an L shape to connect these two. So like this to this. And then you can see there's a 90 degrees anti-clockwise rotation over here. So now, can you tell me the center of rotation?
Is it 3, 6?
Yes, that is correct. Thank you, Harry. So yes, your center of rotation is 3, 6. Okay, very good. So yeah, rotation 90 degrees anti-clockwise from the center of rotation 3, 6. Okay, any questions so far?
No.
All right, then we shall proceed to the next part. Oh my, I forgot that these drawings are following. Okay, hold on, let me clear these, and then we'll move on to the next question. Okay, so from here, diagram below shows 3 quadrilaterals, ABCD, EFGH, and JKLM, drawn on the Cartesian plane. JKLM is the image of ABCD under the combined transformation VW. Describe in full the transformation WV. Okay, this one is a bit difficult, but also not very. Okay, so the first one is you need to remember that. Okay, first we know that we have to remember that ABCD after combined transformation VW will become JKLM. Okay, so which one goes first, V or W?
W?
Yes, that's correct. W goes first. So W, okay, so from here, just by looking at the drawing, are you able to identify what is the transformation W? Okay, wait. I list down all 4 transformations. We have translation, rotation, reflection, and the last one, enlargement. So we know that ABCD, just to remind you, ABCD over here will end up becoming JKLM in the end after VW. Okay, so before we do we find out what's VW, you have to find the individual ones. So we start with W. Do you think W is translation, rotation, reflection, or enlargement?
Actually, I'm confused because it's reflected and also it's enlarged.
That is true. Yes, that is the trick. That is the part that is can be very can be very confusing, lah. But actually, it can be either one, honestly. Like if you extend this over here, if you extend this grid paper like this, then you can do enlargement first. Okay, you get the idea, lah. Okay, wait. I'm not gonna try drawing that. That's gonna be too much time. But yes, if you start with enlargement, that's also okay, actually. But you can do either one actually to start. But generally, the consensus is that for this kind of question, if you should try not to make an enlargement that can go outside of the diagram itself, because this one it will need to take like extra space. Does that make sense? So yeah, try not to do enlargement that will go outside of the picture, basically. So our first step can be, you can say either one, but for this case, since we don't want to enlarge it outside of the boundary, which is over here, because if you enlarge it, it'll become like this, and that would be too confusing, and that will be like outside of the thing. So we start with, before we enlarge it, what should we do?
Reflected.
Yeah, reflection. Yes, that's correct, Harin. Thank you. So we began with reflection. So reflection on what line, Harin? Any idea?
0. Wait.
Ooh.
Is it? I'm not sure. Is it negative?
You can try. You
something?
can try. Just try. Just try. If you
Is
get
it
it wrong, don't worry. It's not like it's school.
negative 4?
Is it what? Say that again.
Negative 2.
Yes, -2. But is it y equal -2 or x equal -2?
X equals to negative 2.
Yeah, that's correct. Thank you, Harin. So x equal -2 will be like this. We have this green line over here to reflect the whole thing. So our first I can't. All right, I forgot I'm drawing. Okay. Okay, so our first one is, okay, so how do you describe the, oh yeah, okay. How do you describe the reflection, Hari?
The image undergoes reflection
Reflection,
at -2.
At -2, close, almost.
Is it at -2? I'm not sure.
Don't worry. It's a learning process. It's reflection on the line x equals to -2. So like that, loh. If it's, so it's like whenever it comes to description, reflection is the simplest one. You just write reflection on the line x equal -2 or y equals something, or it can be something else entirely. Sometimes the line will be confusing like this. Wait, let me try drawing like a certain kind of line. Give me a second. This one, if they do, and that will require both y and x. So watch out for those as well. But for now, we won't look through that. So give me a second. I'll go back here and erase that. So this one is, we start with reflection on the line. So we know that W, transformation W, which is A, is reflection on the line x equals to -2. And then now we go on B. B is asking for V. So this one, do you have any idea? Okay, do you have any idea how to begin, Harry? Okay, actually no, wait. Which transformation is it first?
Is it rotation?
Ooh. Good try, but it's not rotation. Try again.
Enlargement. No, it's translation.
Okay, not translation. But close. Okay, wait. So yeah, we already reflected from A, B, C, D becoming to F, E, F, G, H. So now we want to find out how to make E, F, G, H this big one over here.
Oh, so we have to enlarge it.
Yeah, that's correct. Thank you, Harry. So since we have to enlarge it, what's the two things we need to know for enlargement? Do you have any? Yeah, continue.
The scale.
Yeah, the scale factor, correct. And
The center.
yeah, the center of enlargement, correct. So we have to find these two things. So how do we find the center of enlargement? Okay, to find the center of enlargement, try to find which dot is similar to each other. So for example, okay, we know that L is similar to G. Okay, we know that the dot L is similar to G because this one will become this one. Okay, so which one is similar to H? Which letter? M, correct. And E?
J.
J. Okay, good, good. All right. And F?
K.
All right. So yes. Okay. Thank you, Harin. So we first look at this, and we have to connect these dots, the one that are similar. So we connect these dots like this. L, we connect with G. Oh wait, no, just too thin. Wait, let me just make it thicker. Okay. L, we connect with G, and then we make a long line as long as we want. And then we connect the M to H, and then we make a very long line as long as we wanted to. And we also take E and J, and we connect it like this. And you can connect K and F in the same way. And also, I'm gonna erase the reflection first. So now, where do all the lines intersect?
0, 4.
Yeah, 0, 4. Very good. So yeah, 0, 4 is where all the lines intersect. And this is known as our center of enlargement. So that's how you find center of enlargement. We just connect the dots and then we find the intersection. Okay, so now we're looking for the scale factor. So tell me, do you know what's the formula for scale factor? Or if you're not sure, then you can say not sure.
I'm not sure.
Okay, don't worry. So the formula for scale factor. Oh crap, I actually clicked on something. Okay, the formula for scale factor is, okay. Let me just erase everything here. Clear all drawing. So the formula for scale factor is scale factor, or K, is equal to image side divided by object side. So let's take one of the image sides. Okay, so tell me, I like to ask, line KL, the line KL is similar to which line?
FG.
FG, correct. KL is how many units?
3.
3. Okay, good. FG?
1.
Okay, good. So now that we know this, we can just take image side. Image is the JKLM. So image side is 3. Object will be FG, which is 1. So now that we know this, our scale factor will just be 3. It'll be 3 divided by 1, and you know it's 3. So that's how you find the scale factor. You just take the image side divided by the object side. So from here, we can find out that scale factor is 3. Okay, any questions? Are we clear on this?
Yes, sir.
All right. So now we have to describe this in the enlargement. So from here, we can just type enlargement. To describe this whole thing, make sure you don't write it like this. If you write it like this, then they'll just give you a big fat 0 for your marking. So for this one, the final answer will be enlargement of scale factor 3 from the. Okay, try completing a sentence for me, Harry.
Is it from the object?
From the object, no. Close, very close. Well, not very close, but like some. It starts with the letter C.
Center.
Center, yes, correct. Center of enlargement, which is
0, 4.
yeah, 0, 4. Very good. Okay, that's good. We're going through this one smoothly. So we have A is reflection of the line x equal -2, and V A, which is W, is reflection line x equal -2, and B is enlargement of scale factor 3 from the center of enlargement 0, 4. So this is how you do it. So yeah, this is basically the answers for this. Oh, we have 5 minutes left. Okay. Any questions so far?
No, sir.
All right, then we'll do the last question, which is, oh, where's the last question? Okay, wait, I think I might have forgotten to take the last question. Give me a second. Okay, so we have, yeah, actually this is a continuation of the previous question. Give me a second, let me just take it out real quick. Copy image, and then we can paste that to here. Okay, so it is given that the quadrilateral ABCD represent a region of area. Okay, maybe I should put this with the previous thing. How do I do this? Okay, wait, give me a second. Let me just take this one more time, and then we should be good to go. Okay, copy image, and then we can go proceed to page 7, and here. Okay, so it's given that quadrilateral ABCD represents a region of area 18 meters square. Okay, so we know that the enlargement is scale factor. Okay, we take from the previous slide. We know that the enlargement is scale factor 3. Enlargement is scale factor 3. Okay, it is given that the quadrilateral ABCD represents a region of area 18 meters square. So we know that this one is 18 meters square. Calculate the area of the region represented by shaded region. So we want to know this one, but without this one. Okay, so this one will be a bit difficult, but not really difficult. So we have 18. So knowing that ABCD is 18 in centimeters square, how big is EFGH? Any idea?
18?
Yeah, also 18, yes, because reflection does not change the size. Only enlargement will change the size. Everything else will not change the size. So, wait, give me a second. Yeah, so now we have 8. So we know that this one is 18. So now we have to find the area of shaded region. So we have to find, we know that we have the area of the, okay, we have the object, which is EFGH, for example. Area of EFGH is 18. And this is also the object for the enlargement. Area of object is 18. Now, if you remember our formula from just now, the area of image, this one, the one they'll put in your exam. So if you're stuck, you can look for the formula again. Area of image is equal to k square times area of object. Area of image is equal to k square times area of object. So give me a second. Area of object. So from here, we can find out that, okay, we know that the image is JKLM, because once you enlarge this, you get this one, which is JKLM up. Once you enlarge this one, you'll get the bigger one, which is JKLM. So from here, we want to find the area of object. So the area of object would be equal to the area of image is equal to k squared times area of object, which will be 3 square times area of object, which is, okay, what's the area of the, actually no, the area of object is right there. No, area of object is 18. So 3 squared times 18, we get 9 times 18. You will get 9 times 18. Okay, 162. Okay, now this is a mistake that I quite often made. Is this the final answer?
No.
No, why?
Is it because it's 3 times bigger, so we have to find it?
Close. But we already times it by the enlargement. So that one's already done. Any other idea?
I'm not sure. Is it because no, I'm not sure.
Mhm. All right. Okay, so then I'll explain this part. So the reason why, okay, the area of image. Now let me just take the, okay, this is the area of the object, which is the red part over here.
Oh, can
And
I
we
guess?
also have,
We have to minus it, right?
yeah, that's correct. Very good, Harry. Thank you. So yeah, we have to minus the area of object. So what would be the final answer? How do you find the final answer?
126 minus 18.
Yes, 162 minus 18, and then you will get
144.
144. Yes, very good. Okay, thank you, Harin. And wait, oh no, wait, that's m squared, sorry. Make sure you remember to put your units, because if you don't forget to put your units, then you may or may not lose marks for the final answer left. For the calculation, usually they let you to not use units, but for the final answer, you have to put your unit. So your region represented by shaded region is 144. And that will be the final question. Any questions?
No, sir.
Okay. Any question for the whole lesson? Like for the first question, things like that?
No, I guess.
All right. So if there's no more questions, then Idris, is there anything you want to say? Before we wrap up for today's class? Is Idris here? Okay, if there's nothing else that needs to be said, my name is Adit, and thank you so much for coming to today's class for today's class. And I hope that as a tutor, my lesson will bring you a benefit as a student in your future